6th grade, Module 3, Lesson 16, Classwork. Symmetry in the coordinate plane. Opening exercise. Give an example of two opposite numbers and describe where the numbers lie on the number line. How are the opposite numbers similar and how are they different? So let's just pick two opposite numbers. I'm going to pick like 2 and then its opposite would be -2. So describe where they lie on the number line, how they're similar, and how are they different. So on a number line, if I had 2 and -2, there's 0, -2, -1, 1, 2. So 2 and -2 are opposites because they're both 2 units from 0. 1, 2 from 0, 2 from 0. So they are both 2 units from 0. And we can also say, so their absolute 0, or their absolute value, is the same. So their absolute value is the same. It's 2. So they're different because one's negative, one's positive, or we could say they're different because they're on opposite sides of 0. Okay, example 1. Locate and label your points on the coordinate plane to the right. For each given pair of points in the table below, record your observations and conjectures in the appropriate cell. Pay attention to the absolute values of the coordinates and where the points lie in reference to each axis. Okay, so let's just do one grouping at a time. So let's plot 3, 4, and -3, 4. So 3, 4 would be right there, and -3, 4 would be here. Okay, so what do we notice about these? What are some similarities? So they both have the same y coordinate, 4. So let's say their y coordinate is 4. And their x coordinate, so 3 and -3, are opposites, but it says it wants us to pay attention to the absolute values. So 3 and -3 both have an absolute value of 3, so we can say that their x coordinate absolute value, I'm just going to put AV, is the same. Okay, differences of coordinates. So the difference is, but there's not any difference between the y coordinates, they're both 4, and the difference between the x is that they're opposites. So let's just say x, COOR, I'm just going to start abbreviating. X coordinates are opposites. Okay, similarities in location. So if we're looking at their location, they are both, let's see, 1, 2, 3, 4 units up from the x-axis, and they are 3 units, 1, 2, 3 units out from the y-axis. Both of them, 1, 2, 3, and 1, 2, 3, 4. So we can say that. So let's say both are 4 units above x-axis and 3 away from y. Differences in location. So let's look at how they're different. So they're both both are 4 units up from the x-axis, but the y is where they're different. So one is to the left of the y-axis and the other one's to the right of the y-axis. So let's say 1 is 3 units to the left of y-axis and the other is to the right. And then relationship between coordinates and location on the plane. So we want to know what's the relationship between these coordinate pairs and then where they're actually located on the plane, like what quadrants they're in, how they're reflected maybe. So we can say that the x-coordinates are opposite numbers. We've already kind of outlined that. So they lie on opposite sides of the y-axis. And they have the same absolute value, so both points lie the same distance from the y-axis. And they lie about the same distance from the x-axis, so the points are symmetric about the y-axis. So since they're the same distance from the x-axis, I'm use a different color. So since they're the same distance here, we can then reflect them across this axis, the y-axis, right? They can go back and forth. So let's say we don't have much room to write all of that. So let's just say that they say a reflection across the y-axis takes 1 point to the other. Okay. Let's do the next one. 3, 4, and -3, 4. I'll do it in red. So 3, 4 is where we were before, but now we're going to do 3, -4. So now we're looking at these 2 points, the red ones. Okay, similarities of the coordinates. So they have the same x-coordinate. So let's say x-coordinate is 3, and their y-coordinates have the same absolute value. Because 4 and -4, the absolute value would be 4. And absolute value is the same. Okay, difference in coordinates. So the x-coordinates are the same, but the y-coordinates are opposites. 4 and -4. Similarities in location. So they are both 4 units, 1, 2, 3, 4, 4 units from the x-axis. Was I using red? Yeah. Let's see if they have any similarity to the y-axis. So they're both 1, 2, 3, 1, 2, 3 from the y-axis. Okay, differences in location. So they're both, the similarity is that they're both 3 units to, I guess that makes sense if I drew it this way, to the right of the y-axis, but one is 4 units below the x-axis and one is 4 above. So that would be our difference. So let's say 1 is 4 units above x-axis and the other is below. Okay, and the relationship between the coordinates on the plane, so again, we're just going to talk about their reflection. So we could take the x-axis, this coordinate, 3, 4, and reflect it across the x-axis, and we would get to negative, or 3, negative 4. So let's just say a reflection across, this time it's the, whereas last time it was the y-axis, this time is the x-axis, takes one point to the other. Okay, and the last one, let's do 3. So 3, 4 again. So there's 3, 4, and this time negative 3, negative 4. So negative 3, negative 4 is here. Okay, so similarities of coordinates. Well, they don't have the same coordinates, but both the x and y coordinates have the same absolute value. We could say that. So let's say x coordinates have absolute value of 3, and y coordinates have absolute value of 4. Differences of coordinates. Well, they're both 3, well, one's 3, negative 3, and the other one's 4, negative 4, so they're both opposites of each other. So let's say both x and y coordinates are opposite numbers. Similarities in location. Okay, so let's see, how many units is this one from the y-axis? It's 3. This one's also 3 units from the y-axis, and they're both 4 units away from the x-axis. So we can say both are 3 units from y-axis and 4 units from the x-axis. Differences in location. So the difference is, we could say that, let me pick out a new color again. So this one is 4 units above the x-axis. Well, this one is 4 units below. This one's 3 units to the right of the x-axis, and this one's 3 units to the left of the x-axis. So let's say one is, let's start with 4 units to above x-axis, and the other is below. And one is 3 units to the left of y-axis, and the other is to the right. And the last one, relationship between coordinates and location on the coordinate plane. So this time we need to reflect twice. So we can reflect across the x-axis, and then we could reflect that one again across the y-axis, or we could do it the opposite way. I know it's getting really crowded over there. So let's describe that by saying a reflection across one axis followed by a reflection across the other axis takes you to or takes one point to the other. Okay, now we're done describing it, so let's put it into action. Okay, in each column, write the coordinates of the points that are related to the given point by the criteria listed in the first column of the table. Point S, 5, 3, has been reflected over the X and Y axes for you as a guide, and its images are shown in the coordinate plane. Use the coordinate grid to help you locate each point and its corresponding coordinates. Okay, so for point S, the given point is reflected across the x-axis. So if we were at point S and it was reflected across the x-axis, where would we get? So if I'm reflecting across here, the x-axis, I'm going to get to M, which is located at 5, -3. Okay, let's stick with S. Let's go down the columns. So the given point is reflected across the y-axis. So now let's take it across the y-axis, and we would end up at L, which is -5, 3. The given point is reflected first across the x-axis and then across the y-axis. So first it's reflected across the x-axis, so we go down back to M, and then we reflect it across the y-axis. We're going to get to A, which is located at -5, -3. And then the first point is reflected across the y-axis. So now, let me clear this out. So now we're reflecting it across the y-axis, and then across the x-axis, we get back to A again, which was -5, -3. Okay, so in the second column, we're a little bit more on our own. They haven't plotted any points for us. So let's plot -2, 4. So we'd go to the left 2 and up 4. And we need to reflect that across the x-axis. So here's the x-axis, so it's going to go across the x-axis. So I'm going to go down 1, 2, 3, 4, and then down 1, 2, 3, 4. So I've reflected it here, and that point is located at -2, -4. Okay, then we need to reflect it across the y-axis. So this time we're going to reflect it across the y-axis. So I'm going to move 2 to the y-axis, and then 2 more, which puts me right here. That is 2, 4. Now the point is first reflected across the x-axis. So first we reflect it across the x-axis, which would get us here, down to this one. Then it is across the y-axis. So then I'm going to reflect it that point across the y-axis, and I would get right here, and that is 2, -4. And then the given point is reflected across the y-axis. So the last one, we started here, it's reflected across the y-axis, which gets us here, and then it's reflected across the x-axis, which gets us down there. So we're at 2, -4. Okay, let's do the next one. 3, -2. So I'm going to plot 3, -2 is right there. And first we want to reflect it across the x-axis. Here's the x-axis. So if we go 1, 2 to get there, and 2 more away, we are at 3, 2. Then, if I reflect it across the y-axis, I think 3 to get there, and then 3 more away, that would be -3, -2. The point is reflected first across the x-axis, so where's my starting point? 3, -2, right here. So this is where we start. First reflected across the x-axis, so if I reflect it across the x-axis, I get there. Then if I reflect it across the y-axis, 1, 2, 3 to get there, 3 more away, I am right here. That is -3, 2. So we went across the x and then across the y. And then if I do it first across the y-axis, I'll end up there, and then across the x-axis, I end up here again, which was -3, 2. And then the last one, -1, 5. Is right there. Oh, sorry, -1, -5 would be down here. Okay, let's reflect it across the x-axis. We would end up back up here because we go 1, 2, 3, 4, 5 away to get to the x-axis and then reflect it and the same number of spaces. That would be -1, 5. If the point is reflected across the y-axis, I would then just move it right over here, and that's 1, -5. The given point is first reflected across the x-axis, so first I reflect it across the x-axis, and then across the y-axis. I would end up over here, that is 1, 5. And then if I first reflect it across the y-axis, and then across the x-axis, I'm back at 1, 5. I hope that you were able to follow along with that, and that all made sense. Okay, number 1, when the coordinates of 2 points are xy and -xy, what line of symmetry do the points share? Explain. So if we have xy and -xy. So for example, if I had 1, 2 and -1, 2. So 1, 2 would be here. -1, 2 would be there. So they share the y line of symmetry. They share the y-axis because the y coordinates are the same, so 2 and 2. And the x coordinates are opposites. Which means the points will be the same distance from the y-axis but on opposite sides. Okay, and then when the coordinates of 2 points xy and x-y, what line of symmetry do the points share? So let's say we had 1, 2 and 1, -2. So again, 1, 2 is there, but 1, -2 would be down here. This time they're sharing this line of symmetry, which is the x-axis. So we can say they share the x-axis. because the x coordinates are the same, and this time the y coordinates are opposites. Which means the points will be the same distance from the x-axis, but on opposite sides.